For the PumpSmart manual, we got control versions, PS200 version 5. Beneath us that we're looking at is a configuration and operations guide. The manual and operations guide is very easy. On the single pump applications, we're just going to be walking through the getting started section along with the single pump process. On the single pump process control, we're going to be walking through about 5 steps. Step number 1 is just the locks and passwords. Second step is the motor control and setup. Third is the operations mode. Fourth, we'll be looking at a set point. And then the fifth one would be putting into the pump motor protection configurations. Utilizing the keypad, we're going to be going through some operational status points, and we'll be looking at the locks and the passwords to get into it. The password that we'll be using today will be password 358, which will give us access to the configuration and parameters. So initially, to start up the system, ensure that your power is applied correctly. To do that, there's control wires that are located underneath the enclosure of the ITT PS200 that we're looking at. So by simply inserting a screwdriver into the bottom portion of it, lifting up on it will remove the operational protective covering, and that'll expose the handheld. To access the control wiring, it's located behind the keypad of the PS200. By simply putting your finger on top and pushing on the pull tabs, we'll open it up, and now we'll zoom in onto the control wiring to ensure that it's wired correctly. Now we're looking at behind the keypad on the PS200, we're looking at the termination points. The top part is for the analog, which is the flow pressure transmitter wired in, and then the next one down is also the DC side, which is a digital 24 volts DC. Note that the wiring must be clean, properly mounted into the terminals, and then if we take a look at the grounding strap to ensure that it's grounded amongst one of those terminals. For the drive enabled digital input, note that it's wired in right to the bottom terminal that we're showing here, and in series with it, it's also wired into the e-stop. In addition to the analog transmitter, there needs to be one additional driver. On this example, we have a jumper between terminals 8 and terminals 11, and that will do the drive permissive. To enhance what I just talked about, we can see that the drive permissive is located on terminal 11, and we jumpered that to terminal 8. And this is right out of the Operations and Configurations Manual of the PS200. While looking at the handheld, if it is not jumpered between terminals 8 to 11 on the handheld, on the bottom line, you notice there's a display that says Run Disabled.
Now we're going to enter parameters to set the drive up. We're going to be using a series of about 5 buttons here, so let's look at these buttons first. The top left is the actual button, and that places us back onto the screen that the drive is normally operated from. Anytime you're entering a parameter and feel that you're about to make a mistake, you can reset the drive back away from that parameter just by hitting the actual button. The parameter key is used to place the drive into parameter mode, which allows you to set the drive up by entering various parameter values. Once you're in the parameter that you're after, you can change the value of that parameter by pressing the Enter key. A set of brackets will appear around the parameter value in the bottom line. At that point, you can use the double and single arrow up and down keys to change that value. Let's try this and see how this works. So entering the password of 358, first we must hit the parameter button. And you'll notice that we see our parameter group on line 2. The parameter that's within that group is on line 3, and the value for that parameter is on the bottom line, line 4. We're looking for 10.0 11.02, which is where we're at right now. So let's enter the value, the passcode 358. We do that by pressing enter. You'll notice that the brackets appear around the value. Now let's use the double arrow keys to enter a value of 300. Then let's use the single arrow up key to enter a value of 58. If we hold the key, it will count up through the digits and then count into the second set of digits. We went to 361, so let's use the down key to back down to 358. Once we have the value here, we will press the enter key to save that value. When entering the password, it will take that value and then return to the value of 0. So we're about to set this drive up for single pump pressure control, and if we follow the book, the very first step has us changing parameter 1201, which is the method by which the drive will do its start and stop. Again, let's hit the parameter key to get into parameters. We're in group 10 here, so let's change that to group 12 by hitting the double arrow up key twice. We're at parameter 1201, which is where we want to be to change how we're going to start and stop this drive. If we leave it at 2-wire DI1, it's just an on-off switch into digital input 1 that starts and stops the drive. In our experience here today, we're actually setting this up for hand-off auto, or HOA, which goes into digital inputs 1 and 2. So we want to change this by pressing the enter key. We see the brackets. Let's change this value up to HOA DI1, 2. Press enter. It's now set up for an HOA selector switch to run the drive. The next step in our book states that we need to set up the motor parameter data and then eventually do what's called a MAG ID. We do that by going to group 11. So pressing the double arrow down key, we are at group 11. The first parameter that we're going to be changing, according to the book, is parameter 11.04. Pressing the single up key, we see that on the third line we are changing the parameter number within group 11 to that of being 04, which is motor nominal voltage. In our case, our motor is set up on the nameplate for 460 volts AC 60 Hertz, so we don't need to change this parameter. The next parameter in the book is parameter 1105. Pressing the single up key, we see parameter 1105. It has a default value of 0, and this is the motor's nominal current. We locate that value on the display or the tag of the motor, and we enter the value in here. In this case, the value of the current for this given motor is 2.1 amps. So again, we press the enter key and ramp in a value of 2.1 amps. And then press enter to accept that value. Pressing the single arrow up key will take us to parameter 1107, which is the RPM for the motor. In our example here, our base RPM of 3480. So we change that value by hitting the enter key and ramping in a value of 3480. Sometimes it's easier to go up to the higher number and then bring yourself back down. And then enter. And then finally, our fourth piece of data for the motor is the motor's horsepower. In this rating, on this particular example, the motor horsepower is 1.5 horsepower. Press the enter key, put in a value of 1.5 horsepower, and then enter. At this point, the drive will come up and tell you that a MAG ID is required. Again, following in the book, the process for doing the MAG ID or completing the MAG ID is simply placing the drive into its actual screen by hitting the ACT button. Make sure that on the top left display line we have an L. In this case, there happens to be an R there. We change that from remote to local by pressing the remote local button until we have an L up there. And at that point we press the green button to start or initiate the mag ID. The motor will not turn, but if you're in a quiet room you can hear that the drive is sending current and voltage to the motor to test it. This process should take a very short period of time, typically less than 30 seconds. Once it's done, it displays ID done, and you have a successful mag ID. Now it's time to go on further with our setup. In our next part of the setup, we will be setting or defining the maximum speed for the pump and the minimum speed for the pump. 1401 is the parameter that defines the maximum speed, and by default is set at the value that you entered for the motor's base speed back in group 11. In this case you see that it's 3480. To define the minimum speed, press the single arrow up key to parameter 14.02, and you will notice that there is a default value in there that is equivalent to 25% of the full base speed. The minimum speed for a pump is typically defined by one of three parameters. First would be, what is the minimum speed that the drive or the pump is designed to go to? Second would be, what is the minimum speed that the motor is designed to go to? But the more likely reason or value that defines that speed would be the speed that is required for the pump to overcome the static head pressure, thereby being able to move water forward. In this case here, we are going to leave it at 870 RPM. Next we need to define how is the PID algorithm, or what type of PID algorithm are we going to use to control this system. We said early on that this is going to be a constant pressure based system, so we need to define the PID algorithm as that for PID control. We do that by going into parameters, down to group 11, and changing to 11.03, and we see that by default the value is set to pressure. Other possibilities include flow, level, temperature, and smart flow. The difference between smart flow and flow is smart flow is based on an actual that's calculated by the drive, where flow control requires an external flow meter to provide an actual value back. Next we're going to define the engineering units that are equivalent to the 4 to 20 milliamps that are coming in from the pressure transmitter. In this case we happen to know that the pressure transmitter is calibrated 0 to 100 psi. To define this value in the drive, we go to group 16, starting with parameter 3. Here we see that the value by default is 0.0 psi, and this is for the maximum analog input, or 20 milliamps, that's coming from the transmitter. We change this value by hitting enter and then ramping this value up to 100 psi. Enter. Next, parameter 1604 defines the value for 4 milliamps. It happens to be 20 or 0 psi in this case, so we're going to leave this at 0 psi. At this point here, after defining the analog input values for 4 to 20 milliamps from the pressure transmitter, for base pressure control you are actually ready to implement the driver or turn the drive on and let it do its PID control. The final step to doing this is pressing the actual key to where you're out on the operation display, and up in the very top line we have a set point of 0.0 psi, so we need to enter a set point in there for the PID algorithm to run. We do that simply by pressing the reference key and then using the double and single arrow keys to enter a value for set point. In this case we're going to put the value of 35 psi in there and then press enter to accept that value. Now we are in a position to where we can start to run this pump at 35 psi. At this point here, the drive is configured for operation and constant pressure control. The final step is to enter a set point on the top line. We do that by pressing the reference key and then using the single and double arrow keys to enter a value, and in this case we're going to enter a value of about 25 psi. 25. Press enter to accept that value, and now it's time to initiate the pump for operation. Before we do this, because we had defined parameter 12.01 as HOA DI1 2, we want to start the drive using the external HOA selector switch. To do that, we need to make sure that the drive is first in remote. Looking at the top left hand side of the display, you should be seeing either an R or an L up here. If it's L, you press the remote local button until it changes to an R. At that point, you're ready to start the drive. So we'll start this, and the motor is starting to turn now. And then come back to see it here. Note that the drive is running the output to achieve the set point, which is 25. On the bottom line is our pressure actual, and it is now 25.0 psi. At this point here, we have an operational pump for constant pressure, but we still have the need to apply pump protection. Pump protection would require that we implement smart flow. And then once we have smart flow set up, we can use that to create pump protection for the pump, including dry run, min flow protection, and run out.
To explain the system that we have in the lab and how we're going to demonstrate the PS200 from ITT Gold is we've got their PS200 drive connected to our HOA station, which is the handoff auto switch, including the e-stop. And as we pan to your left, we're looking at a 1.5 horsepower motor with a pump, centrifugal pump, with a pressure transducer. And then we have circulating water that emulates our model here. With on the inlet side, we have two switches, and then also on the discharge switch too.
Next, we are going to implement Smart Flow. Smart Flow is the capability or built-in algorithm within PumpSmart that enables the drive to look at the shaft horsepower. Once we understand the shaft horsepower, we receive that accurately, we are able to use that to tell exactly what the flow is through that given pump with an accuracy of plus or minus 5%. Setup for this can be found in the manual underneath Options and Features, and is done in Group 29. So let's get busy trying to set up Smart Flow within Group 29. First, we need to press the parameter key to get back into parameters, and we're going to press the double arrow key up until we get to Group 29. In Group 29, parameter 29.01 is the type of smart flow, and the default value is 0. We need to change that for the type of pump that we are enabling smart flow on. In our case, it happens to be a single suction centrifugal pump, and that's defined by SS centrif. Enter, and then we're going up to the next parameter. There are 4 pieces of data that are required from a pump flow curve that is required to be put or used in the setup of smart flow. One of them is the BEP, or best efficiency point flow. There is the best efficiency point power, the value for shutoff power, that is to say that if the pump is running against a deadhead, this would be the value of power that we would see. And the final thing is, off of the flow curve, we'll see the speed at which the curves were generated at. That's the speed for the pump. And this is what we're putting in this case. For our given pump today, the BEP flow is 20 gallons per minute. So we need to change that by pressing the Enter key. We see the brackets. Use the double arrow key down until we see a value of 20. Press Enter. Single arrow up key will bring us into the rated speed. And the rated speed on this pump is in fact 3480. So we don't need to make a change here. Press the double arrow up key and it is asking for the best efficiency point power. And so we need to enter a value of 1.1 horsepower, which is our best efficiency power. Press the Enter. Using the single arrow key, we will up this to 1.1. And Enter. Next, we press the Enter key or the up key, and we see that it's looking for the shutoff power. Again, the shutoff power is the power that the motor experiences if it's running against a blocked discharge valve, but yet there is fluid in the pump. So you need to make sure that you have fluid in the pump for this value. We've looked at the curves and determined this to be 0.6 horsepower. So we're going to enter a value of 0.6. Enter. Calculation source is where we are able to now tune this pump to find out exactly where its shutoff power value is in relation to having no flow. Because we have a discharge valve that we can shut down entirely, and because we know that there's fluid in the pump, because we just ran this, then we know that we can actually block that discharge with the valve and determine exactly what, for this given pump, this shutoff power value is. And that's the next thing that we're going to do. So the very first thing we need to do is to close the discharge valve. You're going to have to... Where is it? Hang on a second. Right there. Okay. Let's bring this back now. After closing the discharge valve, the next step is to change this from affinity to tune, and that's done by pressing the Enter key, using the single arrow up key until you see the word tune, and then pressing Enter. Much like that for doing a mag ID, we need to return back out to the actual display. Make sure that we're in local. We're currently in remote, so we press the remote local key until we see an L up there. And then the next thing to do is to press the start key. At this point, the pump is running, and the drive will exercise the pump at 3 speeds. Those 3 speeds include 33, 60%, and 100% of speed. When it stabilizes at each of these 3 speeds, the drive will pick up the power value, and it defines the exact curve for that given pump. This whole process should take less than 30 seconds. Now we have a captured value, and the drive pumps or smart flow is now tuned. Now that we have a tuned smart flow, we can display the value of that by going back to the actual screen. There is a flashing cursor to the left side of one of the 3 bottom lines, and in this case it happens to be on the second line down. I'm going to move that down to the 3rd line, and I want to display the value of smart flow. You do this by pressing Enter, and again keep in mind this is on the actual screen. You'll see that it says it's in group 2, looking at parameter 3. The value of smart flow is group 2, parameter 19, so I need to change this up to parameter 19. And there we go. And then press enter. If you look now, you've actually assigned to the third line the value for SmartFlow. Now we can enter a set point of 25 psi, and we can see what the actual flow is when we are running at 25 psi. So we're going to turn this on and run this. First, we must put it into remote. It's in remote. We're now ready to run the pump at 25 psi and to watch the value that SmartFlow calculates on this third line. Prior to starting this up, we need to make sure that we are in remote because we're using a hand-off auto selector switch, and we need to make sure that the discharge valve has been opened up. Once we have these in place, we can use the hand-off auto selector in auto to run at 25 pounds pressure and also monitor our SmartFlow calculated flow value. In this case here, we're running at 25 pounds pressure, and the drive is holding that constant at 3,031 RPM, and our SmartFlow value says that at this speed we're actually pumping 17.3 gallons per minute. Drive is set up for constant pressure control, and we have defined SmartFlow, which enables us to see what the flow is. We want to try to use that SmartFlow to enable what we call advanced pump protection. Advanced pump protection protects the pump against pump upsets such as, or process upsets such as run out, min flow, or dry run. All of these can be hazardous to your pump and cause failure early on in life. So to set up pump protection or advanced pump protection, we need to go to group 25. Using the up and down keys, find group 25, and then you should be at 2501 to start out with. Let's go to parameter 2503, and we can find this also in the operator manual underneath the advanced pump protection, underneath features and options. But 2503 defines the protection delay, and the protection delay is the period of time that the drive will recognize, or PumpSmart will recognize, the fault condition and will wait this period of time before reporting that. And the purpose of this is to keep you from having nuisance trips. So in this case, let's put in maybe a couple of seconds delay on that. We do that by pressing enter, enter a value of 2, and then we're all set. Now we're going to go up to where we set up the advanced pump protection, and that starts out with parameter 2510. 2510 asks what is the source of the flow signal that's going to be used in the advanced pump protection. By default it's set to SmartFlow. It can be set to an external flow meter. So if you have an external flow meter, you would change this to external flow. We're going to leave this at SmartFlow because we do not have an external flow meter. The next parameter we see is the min flow control. By default it's disabled. We have the option of making that warning or alarm and control. If it's set for warning, what it does is just simply put a message up on the display that you are in a min flow condition, which means that the pump is running at a speed, or there is a flow that's happening that's below the minimum value defined here in a moment, which could cause the pump to overheat. Warnings can be also sent to the digital outputs, which could be used to signal an alarm or horn or whatever the case might be. The other option is to set this up for control, alarm and control. Alarm and control says that we'll get a warning on the front display, and control says it's going to look back at parameter 14.05 to find out what it should do, and 14.05 can be defined as go to minimum speed and stay there, or go to minimum speed for a very short period of time and then cause the pump to go into a sleep mode. And for our case here, we're going to change that to warning and then press enter. The next parameter we're looking at is to define what is the value that we want to define as the minimum flow. And for our given case here, we're going to make that a value of 3 gallons per minute. Next, we're looking at parameter 2513, which is called dry run control. Dry run control is where something blocks flow coming into the suction side, and then the pump pumps out all of the fluid that it has, and it's actually running dry. This can burn up bearings or burn up seals and cause catastrophic damage to the pump. So typically in this case, we don't want to leave that disabled. We want to enable that, but instead of being warnings, we want it to fault the drive. If we get into a condition where dry run happens, we want the drive to shut down and display its fault because of dry running. The next parameter we're going to look at is run out control, run out flow. Run out control we can define as warning, and that's it. Run out control says that we've lost our system's resistance and the pump is pumping full speed out against no pressure loss, and what this does is it causes the pump, or the pump motor if you will, to run in the higher horsepower area and could cause the pump and motor to overheat. So we're going to leave this at warning at this point and say enter. Now we need to define what the runout flow value is, and in this case we're going to define that, because we find this on the curves, we're going to define that as 35 gallons. So I'm hitting enter, and I'm going to enter 35 gallons. Enter. Let's continue on in group 25. And we are actually done. We're done at this point. So now we've implemented the pump protection, and it's time to actually test this capability. Now that we've set up advanced pump protection, it's really time to test it and make sure that in fact it's operating the way that we want it to operate. And we can do that by initiating the pump with both the discharge and the suction side valves fully open. We do that by making sure that we're in remote. Use the handoff auto selector to auto, and what we're watching here is that in fact we're getting pressure towards our set point of 25 psi. We're at 21 right now on the way up, but we're also seeing that we have flow at 20.8 gallons, so roughly 20 to 22 gallons. What we're going to do in this first part of the test is test for min flow. We're going to test for min flow, and as we test for min flow, we should see once we hit below 3 gallons per minute on this display, the second line up, 3 seconds after that we should see a min flow warning come up. So let's start to cut back or throttle back the discharge valve until we see a flow value that's less than 3 gallons per minute. As we throttle back, you can see that, or hear that the pump is speeding up because it's trying to maintain the pressure that's now dropped due to the fact that we're throttling the valve back. As we continue to close this valve, you can see now that the flow is starting to drop significantly. As we continue to close this, we're down to 17 gallons, 16, 15, 14, 13, 12, 11, 10. I'm continuing to throttle the valve back. I'm now down at 6, 4, 3, 2. We're below 3, or we're right around 3 to 4, so I'm going to cut it back a little bit more. Now we're below 3, and it's about 3 seconds now, and there you go, you have a min flow warning. At this point here, I'm going to completely close the discharge valve to see if we can catch a dry run condition. As the valve is closed, we see that we are not catching a dry run condition, and this is true and should happen because in fact there is water in the pump, but in fact it's just simply not flowing. So the next stage of our test is to run the same test that we just did, but to run it using the suction side valve, and therefore we can check and actually cut off all flow to the pump. So I'm going to open up the discharge valve. As it's fully open now, we see that we've come up to the 25 psi. We have a flow of over 20 gallons per minute, and I'm going to run the same test, but this time I'm going to throttle back the suction side valve. As I do this, like the suction side, the speed starts to increase, continues up. I'm trying to maintain that 25 psi. At this point here, my flow is at 21 gallons, so I'm going to keep throttling this back. 15, 12, down to 5, down to less than 3. We have our min flow warning. As I close it off all the way, now I'm starving the pump, and we should see a dry run, which we just did now. As you see on the display, it says dry run, and the pump did fault. The drive stopped the pump so we don't do any damage to the pump. And that is advanced pump protection to protect your investment.
This is test.
This cut is showing just the valve throttling. There's the min flow, turning it off all the way. And while we have min flow, we do not catch dry run because there is in fact fluid in the pump. Now we're going to do the same test with the suction side valve. Can you get it well? Okay. There's min flow, turning it off all the way, and now we have the pump stops with dry run. Now we're going to be setting up smart flow, because smart flow can be used not only to know what the flow is going through the pump, but it can also be used in our advanced pump protection, which we will show you shortly. In the process of smart flow, it's going to ask you for 4 parameters which you can readily find on the pump curves. Those 4 parameters are BEP flow, BEP power, power at shutoff, and then what is the speed that the pump curves were generated at. All 4 of these parameters can be located on a standard pump curves. So let's look at setting up smart flow in group 29. 29.01 is asking what type of pump are you going to apply smart flow on. So we hit enable, or we hit enter, and we press the up key until we see single suction centrifugal, because that's the type of pump that we're doing here. Enter. The next parameter it's asking for is the BEP flow. In our case, we know the BEP flow to be that of 20 gallons per minute. So we put in 20 gallons and then we hit enter. The next parameter, 2903, is asking for the rated speed of the pump. As you can see, it's defaulted at 3480 because of the values that we put in for the motor early on. So we don't need to change that because that's what our rated speed is. The fourth item is the best efficiency point power, which we know to be 1.1. Hit enter, and let's change that value to 1.1. Enter. And then finally it's asking for the shutoff power, and we've determined off of our pump curves that that value is about 0.89, so we're going to change that value to 0.89 horsepower. And enter. Now at 2908 is the calculation source, and it's set by default to affinity, but at this point here we want to tune the Pump Smart and Smart Flow to this specific pump, and we do that by running a tune. Now to run a tune, you must first close the discharge valve, change this to tune, hit enter. At this point here, the drive wants to do a tune. It comes up warning tuning. Press the ACT key. You need to make sure that you are in local, so we hit the remote local key to put an L up there. And then being sure that our discharge valve is closed, we initiate the tune process by pressing the green key. During the tune process, Pump Smart will run the pump at 3 different speeds: 33, 60, and 100% speed. At each of those points, it captures the power value there, and it uses that to know the power curve at shutoff. This process guarantees that the Pump Smart can understand the value of flow within plus or minus 5%. That whole process takes less than 30 seconds. And now at this point, we have a Smart Flow set up, completed in our Pump Smart. This is the taping of multi-pump control using Pump Smart PS200, and what we're going to do is just record parts of it that are different from the single pump. So entering the password is the same as single pump. This next thing that we're going to do is changing the application macro, which is parameter 12.02. We will film that because it is different than single pump. Then it goes into setting up 1201, how to stop the drive, as well as setting up the motor data and doing the mag ID. Those will all be kept from the single pump because it's the same process. So at this very moment, we're going to look at how to change the macro, the application macro, to multi-pump. And the process of setting up the PS200 drive for multi-pump control, the first step is to go into the parameters group 11. So we hit the down key for finding group 11, and we're looking specifically for the application macro, which is parameter 11.02. We see by the bottom line that it is by default set up for single pump, and we want to change that to multi-pump. We do that by pressing the enter key. We need to go into group 11. Parameter 1 is the start. Pressing the up key, we see parameter 11.02. which is now the pump application macro. By default, it's set for single pump. We're going to change that to multi-pump by pressing the Enter key, moving the single arrow up key until we see multi-pump, and then pressing the Enter key again. Now it's time to move on to setting up parameter 1201 and setting up the motor mag ID features. Part of the initial process to setting up multi-pump is to first install what's called the RDCO module, which is used to connect from the drive through fiber optics to the second drive. It's in fact what we call peer-to-peer communications. To install this, we need to remove the cover, open up the door to the display, and you'll notice that there are 3 slots for option cards on the PS200. The RDCO module plugs into the bottom slot, such as that. The next process is to bring in the fiber optics and plug them into the bottom channel 2 of the RDCO module. The process of connecting or plugging in the fiber optic cables into the RDCO module is to bring them up through the conduit box, and we will be plugging them into channel 2. One of the things to note about each of these channels is there are 2 ports. One is dark in color and one is light in color. If you always plug the black into the darker color and the blue into the lighter color on all of the drives, then you'll have success in achieving these communications. So we'll plug that into the light color and the black one into the dark color port. And that's all there is to putting in the RDCO module and the multi-pump. Multi-pump operation. The pump that is the lead pump is defined by which of the pumps gets turned into auto or enabled first. In our situation, we are going to turn the right-hand pump on first, and then we're going to turn on the left-hand pump to auto. Note that because we turned the right-hand pump on first, it started up to control to the set point of 25 psi that we have asked for. As long as we don't have any restrictions, the single pump is able to manage the load demand of 25 psi. Now we're going to introduce some system friction where it's not going to be able to achieve that particular load. As we back or throttle this valve down, the pump pressure is going down. The pump is speeding up to try to compensate for that, but per the way we set it up, if we exceed 5% error between the set point and the actual, and the main pump or the lead pump achieves 98+% of speed, then the second pump will come online, which we just heard it do. At that point, the second pump or the lag pump synchronizes its speed to the lead pump, and they both contribute together to meet the load. Now, if we release that restriction, what we find out is that the speed of the 2 of them will go down because pump A is contributing more flow. Eventually we'll get to a point to where they reach about 75% of their base speed, such as it just did, and now the lag pump just dropped out because the lead pump is able to manage the demand. You'll notice that the lead pump did speed up in order to meet that demand, but it's able to do that on its own.